When Apple introduced Macintosh, we set a new standard for the way computers could make themselves useful to people. That was just for openers. Since then, we've been making the Macintosh personal computer more capable and more versatile. We've expanded our family of peripherals, made it easy to connect with other Macintoshes and other kinds of computers, so that people who use Macintosh have a direct and seamless connection to the resources of any information system. With over 3,000 applications to help people become more effective, more inventive, more productive.
The way most people respond to the Macintosh is to look at it with a sense of wonderment, because they get into the Macintosh and they do things that they wanted always to do. Better, faster, and that's fine. But then they get the Macintosh because there were obstacles. There are things that they couldn't do for lack of a proper tool or for proper instrument. And then they get to write these beautiful documents to prepare these presentations. So they are fulfilling some of their dreams. And then after they've done that, they discover new thoughts because of the new language that we provide them. In other words, once they get over the obstacle, over the mountain range, they discover new territory of things that they can do they couldn't even dream of before they got into the Macintosh.
Macintosh has grown into a general productivity tool with some very impressive specialties, such as helping people communicate with clarity and impact, providing tools for design and modeling, opening new avenues for learning, both on campus and on the job, helping people distill information into knowledge and insight so they can make better decisions, and supporting the programming environments that will help developers around the world continue to extend the range of what you can do with Macintosh. We'd like to show you what's behind the continuing evolution of Macintosh. It's an approach that we call the Open Architecture System Integration Strategy, or more simply, Oasis.
The basic promise of Oasis is that the consistency, the power, the grace, the self-actualization that we provide with the Macintosh, we can move gracefully into the future using new technology and new software development.
Macintosh is the personal computer that established the advantages of a graphics-based human interface. You control it in a simple, intuitive fashion by pointing to menus instead of having to remember and type commands, and by manipulating screen objects that behave like objects in the real world, all of which gives you a direct and straightforward way to communicate your intentions to the system, and an equally direct way to learn the results.
What we do is we study how people work with tools, and there are a variety of tools that are very successful, such as a pencil or a piece of paper. And then we look at how we can more closely model that successful relationship and then create it as a computer artifact.
With Macintosh, various applications, even from different developers, work in the same clear and consistent fashion. And that leads to a very important consequence. People can combine applications to assemble the precise set of tools they require. Because the ultimate question isn't how easy is it to use, but how much can I do with it? The foundation for this consistency and integration across applications lies in the Macintosh architecture. It's an object-oriented design with hardware and software functions grouped into 5 distinct layers, each layer working with the others to provide users with an intuitive and consistent approach to computing. 2 of these layers are unique to Macintosh, the desktop and the toolbox. They give users and developers the software components that command the Macintosh experience. And because the entire system is modular, we can improve the components individually, upgrading them to encompass new capabilities, as, for example, when we brought color to Macintosh. We can make these improvements without disrupting the overall design, and more important, without disrupting the way people work with Macintosh. As our technology advances, we add new modules that enrich each layer of the architecture. This strategy of modular extensibility is the key to the smooth and rapid evolution of Macintosh. It's why people who use Macintosh have a direct connection to the future. Every computer system consists of hardware and software. The software is grouped into an operating system and applications. The operating system directs the way an application calls on such basic functions as input, output, processing, and storage. But when it comes to the way users deal with those functions, every application is on its own, which typically has resulted in a hodgepodge of interface ideas. Macintosh takes a different approach. With Macintosh, the user's view of the system isn't an afterthought, it's the central thought. To ensure a rich and consistent computing experience for users of Macintosh, we've moved beyond the typical three-layer model of computer architecture and introduced two additional layers, the desktop and the toolbox. As we'll see, the desktop supports the user's experience directly, while the toolbox gives developers the tools they need to create a diversity of applications that look and feel and work together in a consistent way. The toolbox has a number of components to manage dialog boxes, windows, menus, and so forth. So, for example, when an application asks for a window, it comes out looking and behaving like a Macintosh window. The application can specify how big to make the window, where to place it on the screen, which window should be active, and so forth. The window manager takes it from there. To call up a menu, the application simply provides a list of items, and the menu manager turns them into working menus. And these menus work consistently from application to application.
What the toolbox does is give you a language, a consistent language that everybody shares, like English, with or without accent. And what the applications on the desktop are poems, novels, stories. So you have a foundation which everybody can count on to communicate, to do things in a standard way. And yet, you have this incredible diversity using the standard language, the toolbox, to do things that do great desktop publishing, great word processors, great spreadsheets, great database programs, great networking devices. So what's very important to our customers and to ourselves and to our developers is the proper layering of what needs to be the same for everything to be harmoniously different.
While the toolbox makes the backstage machinery of Macintosh available to developers, the desktop layer gives users direct control of what happens on stage. The desktop layer lets you manage your system and customize it to your own preferences. Thanks to desktop modules from Apple and other developers, you can get the colors you want, the typefaces you want, or even the calculator you want. Modules in the desktop layer also provide internal connections for bringing data from one program into another, as well as external connections for controlling access to network resources.
At the desktop level, you can arrange your files the way you want on the desktop. The computer will find it for you. You can run an application, write any document you want. The computer will deal with it. You can have any choice of a crazy desk accessory. The computer will deal with it.
A large part also of what our design is to make things very much plug and go, so that people don't have to know a lot about their hardware configurations or how to plug them in to basically make it work themselves. I think one of the wonderful things about the Macintosh is the ability to pull the Macintosh out of a box the first time a user has purchased it and pretty much put it together without trying to fully understand how it works.
The operating system layer connects all of the higher layers to the hardware layer. Macintosh is designed around the Motorola 68000 family of processors. As newer, more powerful processors are developed, we incorporate them into the Macintosh.
These 5 layers give us a sense on how things are architected and work today. But more importantly, they give us a sense on how we can slide a brick out, put a new one, and keep the entire edifice working.
Here's an example of the Oasis strategy in action. Let's roll back the clock and see how the original Macintosh carried out a simple and standard function, reading a file from disk. The user pulls down the File menu, chooses Open, selects a file, and clicks on this button. And Macintosh reads the file from a floppy disk. Here's the way Macintosh processed that request, with components in each layer of the model taking part. The user interacts directly with the application, as we have seen, making a choice from a menu. When the menu selection is made, the application asks the standard file package in the desktop layer to put up a list of files currently on the disk. The user makes a choice, and the name of the file is returned to the application. The application then asks the file manager in the toolbox layer to open the file, and the file manager in turn calls upon the device driver in the operating system layer, which physically reads the file from the floppy disk so the user can work on it. When our users required large-scale storage capacity, Oasis provided the framework for upgrading. A flat directory system would be overwhelmed by the number of files on a typical hard disk, so we modified the standard file package in the file manager to support a hierarchical filing system. To the user and to the application, the change was transparent. When you ask to open a file, you have a view of folders as well as documents. Each folder represents a subdirectory, and Macintosh can keep track of the full path to find the document. But for the user, the action of choosing the file is virtually the same.
The advantages that we get over that are that we tend to separate the developers from the hardware. They don't need to know that they're running on a particular type of video card or they're printing to a particular type of printer, because they know that they're always working with the same graphics package, or the same, in fact, toolbox package, or the same operating system package. We'll add a few more calls, but the basic functionality doesn't change.
Each new storage device in the hardware layer is installed with an appropriate driver in the operating system layer, and the file manager talks to them all. The user can switch drives from floppy disk to hard disk to optical disk and back with a click of the mouse.
It's sort of leave the drivers to us. We tend to basically define an interface to the drivers, and the developer will write a driver to that interface, and we support it. And then the application developer knows he can write to our toolbox, and we'll continue to support that interface. And we provide the peanut butter that goes between those two slices of bread.
The AppleTalk network system allows applications to access files on a network server. Through AppleTalk, the file manager has direct access to files and documents at remote locations.
We designed the AppleTalk filing protocol at the same time as we were designing the hierarchical file system of the Macintosh. And we implemented the AppleTalk filing protocol as a close neighbor working hand in glove with the file manager of the Macintosh.
We're continuing to add new modules to the toolbox to allow Macintosh users to connect with seamless simplicity to a multi-vendor computing environment.
There are more acronyms for square inch in networking than in any other area of data communications. Our job in Apple Computer is to mask that underlying complexity and to preserve the end-user computing experience.
Our objective is to populate the Oasis architecture with networking capability that allows this seamless, empowering extension of the Macintosh user space to resources that are remote, perhaps even across continents.
It is important for people to communicate with one another. That's true in a personal computing environment. I mean, you and I, if we work together, would like to share and exchange information electronically. That's what networking enables. When you take that capability into a business environment, it is important to support the types of connectivity available in those businesses. That's why we get into supporting token ring and Ethernet local area networks or wide area networks such as SNA or DECnet.
The Oasis architecture allows us to integrate new network services into Macintosh. But our goal is to assure that the user's view of the network remains simple and direct. Accessing files on any network is no different from accessing files on a local hard disk.
I think Sadhu has the phrase that the Cheshire Cat, you know, the network disappears, but the smile remains. I love it.
When we look at the future, what will happen is that there will be changes at each and every layer over time, continuously, without disrupting the entire edifice. That's the key point to remember.
Here's a glimpse into the near future, and a few of the ways we'll integrate new technology into Macintosh as we continue to integrate Macintosh into a multi-vendor environment. To handle larger data files and more sophisticated applications, we'll introduce a full 32-bit operating system with virtual memory and multitasking. We'll support inter-process communications and provide a direct way for applications to share data both locally and across networks, giving people better ways to view, analyze, and act on current information throughout an organization. We'll integrate enhanced imaging, video, and sound, as well as 32-bit quick draw, and will extend the ability of HyperCard to access information across networks and through a variety of media, making Macintosh the optimal platform for hypermedia development.
Oasis will help us deliver on a double promise, which is on the one hand, move forward what you have today, bring new applications in a harmonious way, so that technology can be brought in enhancing as opposed to disrupting. More importantly, it will help us deliver on our belief, on our commitment, which is to make someday personal computers the most important tool known to man.
Your graduate research team in Guatemala, just checking in. Robert Jordan, a second semester junior, requesting a second extension on his term paper. And your mother reminding you about your father.
Surprise birthday party next Sunday.
Today you have a faculty lunch at 12 o'clock. You need to take Kathy to the airport by 2. You have a lecture at 4:15 on deforestation in the Amazon rainforest.
Right. Let me see the lecture notes from last semester. No, that's not enough. I need to review more recent literature. Pull up all the new articles I haven't read yet.
Journal articles only?
Fine.
Your friend Jill Gilbert has published an article about deforestation in the Amazon and its effects on rainfall in the sub-Sahara. It also covers drought's effect on food production in Africa and increasing imports of food.
Contact Jill.
I'm sorry, she's not available right now. I left a message that you had called.
Okay. Let's see. There's an article about 5 years ago, Dr. Flemson or something. He really disagreed with the direction of Jill's research.
John Fleming of Uppsala University. He published in the Journal of Earth Science of July 20 of 2006.
Yes, that's it. He was challenging Jill's projection of the amount of carbon dioxide being released to the atmosphere through deforestation. I'd like to recheck his figures.
Here's the rate of deforestation he predicted.
And what happened? He was really off. Give me the university research network. Show only universities with geography nodes. Show Brazil. Copy the last 30 years at this location at 1 month intervals.
Excuse me, Jill Gilbert is calling back.
Great. Put her through.
Hi, Mike. What's up?
Jill, thanks for getting back to me. Well, I guess that new grant of yours hasn't dampened your literary abilities. Rumor has it that you've just put out the definitive article on deforestation.
Aha. Is this one of your typical last-minute panics for lecture material?
No. That's not until,
4:15.
Well, it's about the effects that reducing the size of the Amazon rainforest can have outside of Brazil. I was wondering, it's not really necessary, but,
Yes?
It would be great if you were available to make a few comments. Nothing formal. After my talk, you would come up on the big screen, discuss your article, and then answer some questions from the class.
And bail you out again? Well, I think I could squeeze that in. You know, I have a simulation that shows the spread of the Sahara over the last 20 years. Here, let me show you.
Nice. Very nice. I've got some maps of the Amazon area during the same time. Let's put these together.
Great. I'd like to have a copy of that for myself.
What happens if we bring down the logging rate to 100,000 acres per year? Interesting. I can definitely use this. Thanks for your time, Jill. I really appreciate it.
No problem. But next time I'm in Berkeley, you're buying the dinner.
Dinner, right.
See ya, 4:15.
Bye-bye.
While you were busy, your mother called again to remind you to pick up the birthday cake.
Fine. Print this article before I go.
Now printing.
Okay, I'm going to lunch now. If Kathy calls, tell her I'll be there at 2 o'clock. Also, find out if I can set up a meeting tomorrow morning with, Tom Lee.
Enjoy your lunch. Hello, Professor Bradford is away at the moment. Would you like to leave a message?
Michael, this is your mother. I know that you're there. I'm just calling to remind you to call your sister and pick up.
In terms of a profile of the firm, I guess I should tell you we're at around 10,000 professionals, that we use about 22 different microcomputer technologies, and that we don't have a hell of a lot of problems in integrating 22 different technologies. Now, let me back up, and the reason for that, in 1981 we did a study that took us about 11 months and was summarily let's call it summarized in the Journal of Accountancy. I didn't get a lot of input in the process of the article, but out of it came two terms that have now come, and I feel reasonably flattered at having had some input into the process, to become fairly generic within the technology community, and that is power and casual users. What we found in the 11-month study we did was that we do not have a homogeneous base of users. That we have a group of users that tends to focus themselves more along a line that I will call a power base, and a second set of users that focuses themselves far more along what I'll call a casual base. How does that impact what we do in our technology planning, solutions-driven orientation? Maybe I should share with you a little bit of a definition if we could. Power users rate functionality over ease of use. They tend to use one, maybe two, but more likely one tool. I'll give you an example. Power word processing user wants floating footnotes, a 5 million word dictionary, a screen size about, like bay window, entire document readable in 15-point font, 4 levels of floating indices, automatic grammar checking, and binding and reproduction just prior to printing. Power spreadsheet user wants a matrix something about the size of Texas, 700 built-in financial functions. They also, incidentally, do more than one thing, but they tend to turn or bend the tool to fit the need. Therefore, Lotus 1, 2, 3, which I always have to say in a reasonably reverent sense because it's, somebody told me it's actually being reproduced in the New King James Version of the Bible right after the 23rd Psalm, but he's a power user. Lotus 123 actually makes coffee, hires secretaries, opens doors, and frequently gets used as a word processor by widening the column width to 80 and typing. Power users love 400-page tutorials. You know the guys? They go in the other room and it's a religious experience and they go, oh my God, it sorts. Oh, I love it, love it. Oh, macros. I'm in heaven. They are also the guys that produce a financial forecast that can be run with only one keystroke. They don't worry about relearning a tool because they spend half of their life with it. Okay? They've read the book, they've memorized, they know all of the alternative keystroke command structures, and for them, when F1 through F10 came out, it was honest to God like the 10 Commandments sitting right next to the shift key. Okay? Casual users. They rate ease of use over functionality. If a power user wants the spreadsheet to run fast, the casual user would like the damn thing to just run. And get the right earnings per share. I mean, that's the purpose behind it. The casual user spends 6 hours a day in meetings, 2 hours a day on the phone, and an hour or two in something that might be correlated to technology or assistance with technology. Absolutely refuses to do the 300, 200, 400, 50-page tutorial. Rick, I just don't have time. I got people to meet, clients to serve, kids to grow, personnel reviews to do, budget. I just don't have time to go through this tutorial. Now, here comes the power user, right? I gotta show you 1, 2, 3. Honest to God, it's gonna change your life. Right? Religious overtones are a major part of a power user's vocabulary. Come on over to the house on Saturday. Honest to God, it really is gonna make a difference for you. How about just 4 hours? I'll set it up.